All right, let's see what I can get done in 8 minutes. All right, so we got a factor completely, 64x squared minus 256. Now, there's a couple ways of doing this. If you've got number sense, the easiest thing to do is to pull the 64 from the get-go. That'll give you 64 times x squared minus 4, because 64 times 4 is 256. And x squared minus 4 is a special fat pattern. Takes an x and x to make an x squared. Minus 2 plus 2 will do it, because negative 2 plus 2 is the nothing in the middle, and negative 2 times 2 is the negative 4. So that's one route. The other way of doing this might be to start off a little slow. It's a little harder to do. It takes an 8 and 8 to make 64, and 256 is going to be a minus 16 and a plus 16. So this is the other way of doing it. Now, both of these are divisible by 8. I can pull an 8 from the first factor and make that an x minus 2. I can pull an 8 from the second factor and make that x plus 2. And then I can say 8 times 8 is, by golly gee wow, 64. There you go. All right, number 2, solve. Oh, prove me wrong, but 2 out of 3 of you will miss this. We're going to subtract 64 first. That's what we're going to do. Then we're going to divide by 4. All right, this ain't rocket science, kids. Then we're going to take the square root of both sides. Now, the square root of a negative 16 is imaginary. This is plus or minus the imaginary square root of an actual 16, and the square root of an actual 16 is 4. Are there kids that I teach this year that don't know that? Yes, there are. It's sad that you don't know what square root of 16 is, but you don't. All right, find the inverse of f of x equals 3x minus 7. First thing we're going to do is we're going to swap x and y. We're going to get the f out, make that an x. And then we're going to resolve for y. We're going to add 7. And then we're just going to simply divide by 3. So x plus 7 all over 3 is the inverse of f of x. What's the domain of this logarithm? Okay, we have a property that says for a logarithm with an argument, the argument is bigger than 0. And the argument here is 5x minus 10, and it's bigger than 0. So 5x is bigger than 10 by adding 10 to both sides, dividing by 5, we get that x is bigger than 2. Solve for x. This is nothing more than the ZPP, kids, the zero product property. You take each factor that has an x and you set it equal to 0. And then, of course, you do basic algebra. Some of you will stop right here and you'll be like, I don't know why I'm doing so bad in math. Milbrath is hard. No, I'm not. You just don't try. All right, so I've subtracted 8 divided by 2. I added 1 divided by 2. Let's see the hard one. All right, division happens in the denominator. So I'm going to take that 7 and put it in the denominator, and then 7 times 4 is 28. Easy peasy lemon squeezy. Find the zeros of this guy, simplify your radical. You're probably going to use the QF. So your little song goes x equals negative b plus or minus square root b squared minus 4ac all over 2a. Let's see here. B is negative 8, so x is going to be a negative 8 is positive 8 plus or minus square root of b squared, negative 8 squared, minus 4 times a, which is 3, times c, which is 1, all sitting pretty over twice a, and again a was 3. Now what do we have inside the radical? Should be using an arrow, not an equal. We've got 64 here. 4 times 3 is 12. And then times 7 is what? 84. So I got 64 minus 84, which is negative 20, which is not going to be real. So we're not going to stop there. The root of negative 20 is the imaginary root of 4 times 5. And the imaginary root of 4 is 2i. So I got 2i root 5. You can see I got 8 over 6 plus or minus 2i root 5 over 6. 8 over 6 reducing down to 4/3, and then 2 over 6 reducing down to 1/3. So 4/3 plus the imaginary root of 5 over 3. Moving forward to number 7, factor this bad boy by grouping. So if I focus on the first two, I notice they both contain an x cubed. So I'm going to pull that x cubed. That's going to leave me with x plus 4. If I focus my attention on the last two, I notice they both contain a negative 7. If I pull a negative 7 from negative 7x, I have x. If I pull a negative 7 from negative 28, I have a plus 4. which is cool because that factor had to repeat. So both terms possess x plus 4. You'll notice that we think about this guy and this guy. They both contain x plus 4. And the stuff left over is x cubed minus 7, which does not factor nicely, so we're going to stop. Number 8, given that f of x is 3x minus 2 and g of x is 2x plus 1, find f composed of g composed of x. Old school looking like that. Okay, so what I'm actually finding is f of 2x plus 1, which means that every x in f becomes 2x plus 1. So I I saw a 3, I saw an x, I made it 2x plus 1, and now I'm going to take away 2. I'm going to do the distributive property, and then 3 minus 2 is 1. 2 out of 3 of you will miss that, prove me wrong. Last one, then the class has got to start. Given f of x is 3x minus 4, g of x is the square root of 6x minus 4, find f of g of 4. We're going to start right here. First thing we're going to do is we're going to find g of 4. Everywhere we see an x, we're going to become a 4. Now that's going to become square root of 20 because 6 times 4 is 24. Take away 4 here, that. Let's go ahead and simplify the radical here. This is the root of 4 times the root of 5, which is 2 roots of 5. So our new goal, now that we have figured this piece out, is to figure out what f of 2 roots of 5 is. Well, that's a 3. There's an x. She becomes 2 roots of 5. And then take away 4. 3 times 2 roots of 5 is 6 roots of 5. And then we're done. And I'm done too, because that was the bell for classes to start. So I'll try and finish this up in another video at some point in time today. But I got most of it done. Almost half.